Hello, this is CC615 Cloud Infrastructure class, Week 5 Infrastructure Services and Cloud Architectures, Part 1. This week you will learn first about application programming interfaces or APIs. We will define them and then we will talk about infrastructure as a service APIs in particular and infrastructure as code. Next, we will cover some auxiliary services in infrastructure as a service environments such as security, monitoring cloud deployments, and database services. You will also learn about typical cloud infrastructure as a service architectures, including single server with services, application with security zones and on-premise IT connectivity, load balancing, auto-scaling and database replication, fault tolerance and high availability, and fast delivery of static content with object storage and content delivery network. Those architectural components can be mixed and matched as needed, and they will illustrate the concept we have learned in the first 4 weeks of our class. Infrastructure as a Service Application Programming Interfaces, or APIs. What are APIs? The majority of applications we users are familiar with are intended to be used by humans and are equipped with human-friendly graphical user interfaces, or GUIs. Cloud vendors also allowed customers to interact with their offering via web portals with GUIs that allow for manual provisioning and controlling of cloud offerings. But these days, computer programs tend to talk more to each other than to humans, and the communication language they use is based on application programming interfaces, or APIs. For APIs, the business domain of a computer system is modeled by creating its data model, defining system entities and their relationships. The functionality of a software system is then made available as a library of function calls, taking data elements and entities as input arguments and returning processed results. The fact that virtual cloud infrastructure elements, including compute, storage, and network, are defined and controlled by software makes them particularly suitable for programmatic interactions. A very popular API style is REST, which stands for Representational State Transfer. It assumes client-server stateless communications. No interaction state is persisted between calls, and all resources needed are passed as arguments or returned as results. The protocol of the web, HTTP, fits this style particularly well with its simple get, post, put and delete operations. See the link provided for more information about REST. The REST API style fits nicely with cloud deployment models because it works well with horizontal scaling. Most cloud vendors make their infrastructure as a service offering APIs in the form of REST libraries. In addition, they offer development kits for popular web programming languages, allowing the calls to be made from programs written in these languages, as well as command line interface or CLI packages, which help write command scripts. This fits well with another cloud application programming style, polyglot or multi-language programming. The importance of API is leading to creation of API economy, software vendors defining, running and selling API access to their systems to be accessed by other software systems over Internet. Infrastructure as a Service APIs. In most cases, cloud infrastructure as a service providers use their API call libraries when implementing their web portals. Therefore, customers can invoke most of the same functionality using APIs as when using the cloud provider's web portal in a browser. They can provision resources, manage and monitor them, retrieve billing information, etc. The API call arguments have to include the authentication information to make sure the call is authorized. Below, you see an outline of a REST call, which when put into a web browser will start an instance with the given ID in Amazon Web Services, and you see the authentication parameters at the end, and their exact form depend on the vendor. Cloud APIs make it possible to write programs that define the dynamic virtual environment in which the deployed software will run. This opens an entirely new set of possibilities in deploying and developing software, leading to fully automated DevOps and self-configurable software systems. See the links provided for more information about APIs of AWS and Azure. Infrastructure as code. To help create and control cloud resources programmatically, most vendors provide a way of textually defining resource configurations so that they can be both human and program readable. This capability is called commonly Infrastructure as Code, or IAC. Compute, storage, and network resource configurations can be described as templates using notations like Java Simple Object Notation, or JSON, or YAML, which actually stands for YAML Ain't Markup Language. These notations allow for textual representation of nested structures using name-value pairs. Templates may be parameterized so that they can be reused. Amazon AWS has a template feature called CloudFormation. For more information, see the link enclosed. Infrastructure as Code allows for describing complex deployment structures as templates and automatically deploying them via command line interfaces or APIs. It is a very powerful feature, providing for ultimate cloud automation.